Hello everyone, this is my next video lecture regarding class 12th chapter P block elements, and in this lecture I will discuss group 15 with you, and the physical properties of group 15 will be discussed with you by me here. So this I have discussed with you in the last video lecture where I have discussed the periodic properties. In that I have discussed the S block, P block, D block, F block and everything about this periodic table. Now in this lecture I am going to discuss this P block, and even in this P block especially this group number 15, that is a nitrogen family. So this is the pick of a video lecture I have discussed with you in earlier lectures where I discussed with you about the trend of the elements in P block starting from group 13 to group number 18. So by going to that video lecture you can remember easily these elements and how these are arranged, how to remember them, how you can remember easily their atomic numbers. So the features of P block elements, we know that P block elements are existable in the periodic table. These elements are usually good conductors of electricity. They have a shiny luster. They are good conductors because they have a tendency to lose the electrons. So the amazing elements which exist in P block, especially in this block, we find some of the most amazing and diverse properties of elements like gallium. It just melt on your hand. It is a P block element. It is a metal basically which can melt in your palm. So on the other hand, P block elements also have a silicon which is a metalloid and is a good component in making of glass. These are the some amazing elements of P block. So now moving to the P block elements, we have group 13 to group 18. So in group 13 we have a boron family. In group 14 we have a carbon family, which is the syllabus for class 11th. If you are a student of class 12th, so you might have been studied that group 13 and group 14 in your 11th standard. So now group number 15, group number 16, group number 17 and 18 will be covered by me with you in these video lectures. Here I am covering group 15 physical properties. So group 15 is a nitrogen family, and group 16 is oxygen family, group 17 is your fluorine family, group 18 is your neon family. One more thing I want to tell you that carbon family have another name tetrals, whose name is derived from Greek language, means tetra, means 4. So we know that carbon family have 4 valence electrons, and in a nitrogen family we have a group 15, its another name is nicogen. So it is because from the Greek word to coke, so they get to regenerate or from the atmosphere, so they are nitrogen family. Oxygen family name, other name is chalcogen family, which means chalcose. They are generally get obtained from the ores in the crust of earth. Fluorine family, it's also a halogen family. It is a Greek word name after the salt or a halos. So fluorine family is used to make the salt. Neon family is inert or noble gases which remains neutral. So one thing more, you have been checked my last video lecture also that I have written this P small, even this S is small, this D and F. So make sure always write S block, P block, D block and F block with the small alphabets. Now this is the overview of a P block. Now we will discuss the physical properties of a P block. Here I am going to discuss the atomic size, ionic radii, ionization enthalpy, electronegativity, metallic and non-metallic character, allotropy, catenation, melting and boiling point, density. So this is the scenario which exists in a periodic table whole, but today in this lecture I will discuss only group 15. So properties which exist in group 15 varying with group 14 or group 16 and 17, so on. So first property is atomic radii. You know what is atomic radii? The size of the atom. In last lecture we discussed while moving from left to right, atomic radii decreases, and moving from top to bottom, atomic radii increases. So the reason remains the same. So this is the scenario of the size. We can say if this element have this much of size, then while moving from this to this side, this size goes on decreases. So we can say that the size of the group 15 atom is bigger than the group 16 but smaller than the group 14. Similarly, moving from top to bottom, we get increase in size. So here I have discussed structure of two atoms. One is of neon, other is of nitrogen. As you know that nitrogen exists on this side and neon on this side. So neon must be of smaller size and nitrogen must be of a bigger size. So this is the demonstration of a nitrogen, and this is demonstration of a neon. This is the first shell, second shell, third shell. This is the first shell, second shell and third shell. Both shell, as you know that, are both atom are in a second period. This here represents the period 1 2 3 4 5 6 7. So I have discussed two elements from period number second, which represents that both are having the same number of shell, but only the variation of size is there because of the increase in nuclear charge. Here we have a 10 nuclear charge, here we have a 7 nuclear charge. So because of that, this atom size is bigger in comparison to this one, because hold of this nucleus towards the electron increases in comparison to this. Even more, here we have 1s2, 2s2, 2p3 configuration for nitrogen, depending upon its atomic number. Similarly for neon, we have atomic number 10, so its configuration will be 1s2, 2s2, 2p6. And how to fill this configuration I will discuss with you later on videos. So this is the scenario. While moving from this to this size decreases, and this is I think a good representation to you. You can check by yourself that this atom has a bigger size in comparison to this one. So what is ionic radii? Basically ionic radii is the radii of the ions. The ions are of two types, cations and anions. By the removal of an electron we have a cation, by the addition of electron we have an anion. Here it representation of a chlorine atom, chlorine having atomic number 17, number of electron 17. When one electron add on it, we get nuclear charge remains 17 but electron becomes 18. So with that the size of atom increases, and we can say that power of the nucleus not remain same as here. So this atom becomes little bigger in size. So this is a scenario of a parent atom X, and we have discussed in the last lecture that simple atom have a small size in comparison to its anion and a smaller size in comparison to its anion. Ionic radii, we know that a simple atom or a parent atom have a smaller size in comparison to its anion, as the addition of one electron take place to the parent atom and the attraction of the nucleus with the electron will not that much as it is in a parent atom, so the size increases. This is a demonstration of a parent atom with anion. Here anion is of bigger size, and when removal of electron will take place, this attraction increases and size decreases. This demonstration is of a cation and anion formation, where chlorine atom, parent atom, have a nuclear charge 17, number of electrons 17. By the addition of one electron here, we get Cl negative. This Cl negative atom, that is your anion, will be of a bigger size because of the addition of electron. Here the nuclear charge as remains same but number of electron increases, so number of electron will be 18. So when the number of electron increases for the Cl negative, the attraction of this nuclear charge, which is 17, remains same for cation, anion and parent atom, will have a lesser power to attract the electron or hold the electron. So this is the reason that this atom get bigger in size with respect to the parent atom. And if we talk about cation, here the removal of electron will take place, so minus 1 electron. So we have atomic number 17, it remains as such, while the formation of cation or anion, atomic number does not change and number of electron changes. So number of electron will become 16 now, and nuclear charge also remains same. So by removal of one electron, now nuclear charge is 17 and electron are 16. So with respect to parent atom, here the electron decreases, so nucleus has a more charge to attract the electron toward itself, so that the rest of the electron cannot easily go. So this is the reason that cation are of the smaller size. So this is the scenario of cation and anion, that cation are of smaller size than parent atom and anion is of bigger size than parent atom. Now these questions are for you. Try yourself by these properties which I have discussed with you: atomic size, ionic radii. Moving to next, ionization enthalpy. So ionization enthalpy, I discussed with you in the last lecture that a tendency of an atom to remove an electron from the valence shell of an atom. So in nitrogen family have sufficiently high ionization enthalpies which are more than the corresponding elements of carbon family, because with respect to carbon family, nitrogen family have smaller size. So as we move down the group, ionization enthalpy decreases because size increases. So reason is because down the group size increases, so force of attraction of the nucleus toward the outermost electron decreases. As we move from left to right, from group 14 to group 15, ionization enthalpy increases as size decreases. But with increase in ionization enthalpy, this increase is rapid because as we move from carbon to nitrogen, configuration changes from 2p2 to 2p3. And here in 2p3 we know we have a half-filled p orbitals. So half-filled p orbitals are stable than the partially filled p orbitals. Therefore, the ionization enthalpy goes on rapid increase from carbon to nitrogen family. And this scenario I discussed with you in the last lecture also. By this sum up, I can say that ionization enthalpy is proportional to the atomic size. That is inversely proportional. 1 upon atomic size. If atomic size is more, ionization enthalpy will be lesser. If atomic size is lesser, ionization enthalpy will be high. So these are the questions you can do yourself by using the ionization enthalpy, how it changes while moving from group and in a column in a period, how it changes. So now next property is electronegativity. Electronegativity basically I discussed with you last lecture also, but again I want to say some few words about this, that basically electronegativity is the tendency of an atom to attract the shared pair of electron toward itself. In a layman language I can say that if out of if two person are good friends, for example hydrogen and chlorine, and one is little rich, chlorine is richer than hydrogen because chlorine is having a 17 atomic number, hydrogen is having a 1 atomic number, and when the bond formation take place between hydrogen and chlorine, they use their one electron. As we know that bond formation will take place by the addition or by the use of one electron from each atom, so they form a single bond. One electron is from hydrogen, other electron is from chlorine, and this is the representation of a bond. But chlorine is richer because having a more atomic number, so the shared pair of electron, this shared pair of electron which is by the hydrogen and chlorine, get attracted toward the chlorine, and this attraction and this tendency of attraction toward itself by the chlorine, this is known as the electronegativity. So the power, if someone has a power to attract the people, so we can say that he is electronegative. Now this is the electronegativity. Here I will discuss according to the group 15 the elements of nitrogen family. Those are having a general configuration ns2np3 are highly electronegative due to small atomic size and requirement of only 3 electrons to have fully filled configuration, that is ns2np6 configuration. So nitrogen is a maximum electronegative, or we can say most electronegative in its group, and the value goes on decrease as we move from top to bottom, because as moving from downward the atomic size increases. So we can say that with increase in atomic size electronegativity decreases, and with decrease in atomic size electronegativity increases. Now the next property is your metallic and non-metallic character. Basically metallic or non-metallic character I have discussed again, and in the nitrogen family this metallic character or non-metallic character is goes on increasing down the group. So we can say that first two elements of a group 15 are non-metal, next two are metalloid or semi-metal, and the last one is your metal. So while moving from top to bottom, we can say that metallic character increases because while moving from top to bottom, at size of atom increases, and due to increase in atomic size and decreasing ionization enthalpy down the group, the release of electron become easy downwards. Since metallic character is linked with the electropositive nature, it decreases down the group because size increases. So we can easily remove electron, and we can correlate the electropositive character and metallic character with the atomic size. With increase in size metallic character increases, and on moving from top to bottom non-metallic character decreases. So now next is your allotropy. Allotropy is basically the property in which metal can or element can exist in more than one form. So here in this family, except for nitrogen and bismuth, the remaining elements show allotropy. For example, phosphorus, it exists in white, red, black, scarlet and violet type of allotropes. Arsenic exists in grey, yellow and black, and antimony exists in yellow and black. So what is catenation? Next property, I know You know this property also, it is a self-ringing property. So we can say that as a result of catenation, two or more atoms of a same type can form bond or a multiple bond with each other. Starting with the group 15, nitrogen. The size of nitrogen atom is quite small and two atoms of nitrogen can be linked with each other by covalent bond, resulting in the formation of N2 molecule with the triple bond in 2 nitrogen. So this is quite stable, and this is the reason that this N2 molecule is inert, which do not react easily, and because it contains triple bond and with the dissociation enthalpy is 946 kilojoule per mole. This molecule N2 has a high dissociation enthalpy, so this is the reason that this N2 molecule is chemically inert. And further, more compounds can be formed by nitrogen with hydrogen, that is hydrazine, where 2 nitrogen and 4 hydrogen are present and they are linked with the single bond. So now rest of the elements of the nitrogen family, phosphorus and rest of the family cannot be linked by multiple bonds due to the bigger size and weak dissociation enthalpies. They undergo catenation but exist as a polyatomic molecules via single bond. For example, phosphorus form P4, arsenic form As4 and antimony form Sp4. So P4 exists in a red allotrophic form. P4 molecule are further linked in a polymer to make a polymer. The reason is this: because of the difference in the nature of bonding, molecular nitrogen is a gas, so by the other molecules of this group are solid. So this is one reason that nitrogen show different behavior. It exists in the form of a gas. Now the next is your melting and boiling point. As you know that melting point depend upon the force of attraction. More is the force of attraction, more will be the melting and boiling point. So in group number 15, the melting point of phosphorus is more than that of nitrogen. As arsenic has a very high melting point, then the value decreases, and after that the value decreases. Reason is that both nitrogen and phosphorus are non-metal, in which melting point is linked mainly with the magnitude of van der Waals forces. These are more in molecular phosphorus, that is P4, than in molecular nitrogen due to the bigger size of phosphorus and due to the smaller size in nitrogen. Arsenic has most of its characteristics similar to the metal because it's semi-metal, therefore it has a very high melting point. The decreasing trend in melting point is moving from antimony to bismuth because due to the increase in the atomic size, decrease in the strength of metallic bond and bond dissociation is lesser, therefore metallic point decreases. So moving with the next property, the last property, that is the density. The density of element present in the nitrogen family increases down the group because increase in atomic mass, and you know that density is directly proportional to mass because density is equals to mass upon volume. So if mass increases, density also increases. These are questions you can try yourself by using these properties. Hopefully you like this, and this is the scenario, a compact scenario where all the properties are linked up. Electronegativity, ionization enthalpy are lying this side, electronegativity and atomicity, ionization enthalpy lying this side, and this is the scenario. You can just check by yourself that I have discussed with you all, and this is the in short summary of periodic table. You know very well now, and by this I will finish my lecture today. Hopefully you like this. If you have any type of a query, you can ask in the comment section. Thank you.